Hello and welcome back. So in the last episode we managed to get the room collections fading in and out entire rooms. And as mentioned, the next thing that we're going to sort out is the occlusion effect that we have going on. What we want to do with it is we want to basically stop it if we don't need it. Right now, it's always active, even if we have a straight line of sight to the character. You can see that the environment here is still fading out. So we're going to fix that right away. And then we're going to sort out the dynamic objects in the room collections. So let's get started. The first thing that we're going to need to do is go to our parameter collection that we've been using just for so far on the player location. We're going to add another parameter here, and this one's going to be a scalar parameter, and we're going to use basically like a global value to affect the occlusion size on all objects, and we're going to call it exactly that, occlusion size. And you might remember in the material in environment mask or in the material function, we already have one that's called occlusion size. We're going to replace that with the one in the parameter collection. So I'm going to initialize the value to, actually we're going to leave it at 0 because we don't want it by default. If we go back to the environment mask, I can delete that and drag out and do parameter collection parameter. Select the parameter collection and select occlusion size. So there we go. By default now, if we hit play on the game, once everything recompiles, I'll be able to show you. Cool, so now that's recompiled, you'll notice that we no longer have that see-through effect. So now we want to reintroduce it. And the way we're going to do that is we are going to go inside the BG3 camera. And essentially, like we did for the environment actor where we have a fade in, fade out event, we're going to do exactly the same thing in the camera, but we're going to trigger that just for the occlusion size. So we're going to make a new custom event down here in the camera called occlude environment. And we're going to add an input bool called b should occlude. And this is going to determine whether we're fading in or fading out, just like the other one. So we can branch off of that. And off of true, let's do a timeline once again. And let's call this something like occlusion fader. And just like the other one, we want to open this up and add a float track. Let's call this alpha. I like to use the name alpha. Really, you can call it whatever you want. The reason I like to say alpha is because I generally use a float curve for values between 0 and 1. And then outside of the timeline, I use that in a lerp function to go between two values. So I don't have to have it always set inside the timeline. But of course, you can set direct values inside the timeline, and actually that's what we're going to be doing here. So instead of going 0 to 1, what I'm going to do is I'm going to add 2 points. First one's going to be 0, 0, and I'm also going to right-click and make it an auto curve, just so we get that nice curve. Then I'm going to select the other one, and let's do 0.25. I want this to be a really quick fade in. And the value that we're going to have for it is, let's try that 120 we had for the base value previously. And if we do the zoom to fit, we can see that curve nicely. Next thing is we need to bring the total length of the timeline down to match this track, 0.25. And then, back in the event graph, we can basically hook that value up. Actually, I'm going to not call it alpha because it's not 0 to 1 this time. I'm going to call this straight up occlusion. And I can plug that occlusion straight into a set scalar parameter value. And from here, we can hook it up to update and select our parameter collection. And from the dropdown, select occlusion size. So there we go. That's basically that. If we hook false up to reverse, that's that. But I'm going to add a little bit of extra logic. I want the fade in to be quicker than the fade out. All right? Yeah, I think that's right. So what I'm going to do is I am going to get the component occlusion fader. So this is the timeline component. And I am going to set play rate. So this is how fast that timeline actually takes place. And for the top one, I'm just going to leave it at 1 because I want it to be that 0.25 play rate that we've already got. But when we reverse it, I want it to play much slower. I'm going to do 1/3 of the current value. So it takes 3 times as long to fade out than it does to fade in. So now that we've got the occlusion fader set up, we now need to figure out where we want to trigger this logic from, right? And if we look above it, we already have a trace checking for environment actors. Now this is checking for the room collections, as we've set up previously, but we can multi-purpose this trace to check for hitting anything else as well. So what we want to do for the occlude is we want to occlude the environment if we are hitting an environment actor, right? So we could set it up very simply just like this, if we drag that back, and say, if we hit anything, occlude the environment, right? But this will also trigger if we're only hitting room collections, which we obviously don't want. So how we can set this up to avoid that is say, so we want to occlude the environment only if we're hitting an environment object that isn't counted as a room collection. And the way we can set this up is we can say, let's add another variable here, and we'll call this B colliding with environment, or should we say B environment blocking character. That's better. So now that we've got this, what we want to say is, let's drag this back a bit and clean this up. I noticed this just previously. We've got an empty branch here that's absolutely useless right now, so we can just delete that and plug that back up. What we want, where do we want this? So the room collection, if we're hitting nothing or only room collections, we don't want to occlude, right? So if we have an instance where we go through this and we're casting to the room collection and it fails, we can say the environment is blocking the character and set that as true. Compile and save that. And what I will do actually before this starts is we're going to set this as false. So every time it loops through this, it sets it as false by default. And we're going to plug that in right before the trace off of the sequence. And if it is blocking something, we then want to trigger the occlude environment function that we've got, or the event. So we can drag from completed and say occlude environment, and we want to check that variable that we just made, environment blocking character. If we compile and save this now, let's give it a test. Let's see how that works. And I will full screen by hitting F11. You can see that we've got the occlude back nicely working now. And as we move the camera around, you'll watch the fade effect disappear as the box collision no longer hits anything, or the box trace. And you can see it fade in and out nicely as it touches it. And we can see that more with stuff like this, where it comes into effect nice and quick. So there's not really any danger of you colliding with environment in a way that's obstructive. And yeah, let's see how that works with the room collections as well. So this building probably isn't the best for testing because there's not a lot of open rooms, but you can see he's inside the room collection and we've got a clear line of sight to him, and it's not starting the occlusion, but if we move the camera around a bit, it hits the wall again and we've got it working. So that's nice. If we move him in, you'll see the top of the box kind of hits that environment again and it triggers the effect. So that's working. What do we want to do now? There's a few other cleanup steps I want to focus on this episode. So if we go back into the camera, I want to set up stuff for dynamic objects now because we've been kind of neglecting it for a little bit, and I want to add some logic to get that working. So where do we have in dynamic objects. We want to do that in the room collection. So we open the room collection, and we have static objects and dynamic objects, but nothing really controlling what goes in dynamic objects. So let's set that up now. We already have a box trace here. If we scroll down to the bottom, we can grab on component begin overlap and do the same thing again for end overlap. And we want to start adding logic for when dynamic objects, be it characters or anything else moving around the world that we want to occlude when it enters one of these rooms, we can add that to the dynamic object list once it hits that box and remove it once it leaves. So we can check the other box and say if it implements the transparency settings interface and return to a branch. If it does include that transparency settings interface, then we want to add that object to dynamic objects. So not set, we can grab dynamic objects and add unique, because we only ever want one instance of these objects. And we will add that other actor. Clean it up a bit. And we also want to get the fade result that we currently have going on. We want to check if the room collection is in fade mode or not fade mode. So we need another variable added here called be faded. And we're just going to set this up off of fade room. So if we drag that back and add be faded, we can just set that to should fade. And if it is faded, well, what we can do is do a branch check and just check if it's faded or not. And off of that, we want to get that dynamic object and trigger the fade messages that we've got. So if it's entering for the first time and the room is already faded out, we want it to fade out again. So if it's faded, we fade out. If it's not faded, we fade in just in case. And for removing it, we want to trigger the same logic. So if the other actor is in dynamic objects, so we can grab that and say remove. We want to remove the actor that we hit. And if the actor is not in dynamic objects, then it won't matter. This will return a branch if it's in it or not. Do we need to do anything with that? Probably, yeah. So we will branch it off, and we want to... Do we need the faded? I think we always want to fade in if we're leaving, right? So let us just hook up fade in. And another thing before I forget is in the environment actor, we have is faded, and we're checking faded on this, but we're not actually setting this anywhere. So let's set that up now. So on fade in, it's not faded, and on fade out, it is faded, just in case we need that for anything. So now that we've got this set up, and of course we are forgetting to hook up fade in and fade out. Or what I'll do as well is I will add another reroute. Just branch from this one. So we can compile and save that. And now we want a dynamic object to test. So let's make a quick test actor. If we go to, where do we want to make this? Let's just do it in camera because we're already doing everything in camera. Let us make a new actor, blueprint class, actor, and we'll call this BP floaty sphere. We load him up, and we want this to include the transparency settings, so we can go down to implemented interface and do BPI transparency settings. Compile Compile and save that to get the events. And we want to just copy everything that's here in environment actor. Where'd that go? Floaty sphere. And yeah, we will just right click and create a variable for these. For the static mesh, we want to add a static mesh. And that should fill that in. And we'll leave it like that. And then material instance, oh, we also want to do that, don't we? So environment actor, let's also copy this. Generally, if you have two actors using the same logic like this, I wouldn't recommend making a new actor class and copying everything like this. But I just want to kind of indicate that, you know, we can have other actors that has the same logic or similar logic on similar events, even if they're not the class that has, or that we're setting up for other things. Like this could be a character, for example. I didn't really explain that well, but all I'm saying is you can add this logic to any actor, and it doesn't have to be an environment actor specifically. So we've got that, and static mesh, and let's just add a sphere to the static mesh. Let's see. Scroll down, find a random one. It's a massive one, I think. Let's check. Yeah, that's a massive one. Let's shrink that down a bit. Scale, we'll put it 0.25. Yeah, that looks nicer. And we're going to have some logic that just pushes him back and forward through a wall. So let's go to event graph. And on begin play, let's also set up a timeline. Add timeline. Movement. So yeah, this is just for testing. This actor isn't really useful for anything else. On movement, we'll load that up and add a float track called alpha. And add 2 points. We're going to move the first one to 0, 0, and let's do 3, 1. And we'll make the length 3 as well. Compile and save that. And the lerp, we want to lerp vector off of the alpha, sorry. And we want to set actor location. So it's just moving back and forth between these two. Actually, that's a good point. We're not actually moving forward and back, we're just moving forward. So let's double that up to 6 and add a new frame. Make it 6 and 0. Make it an auto curve. So now it's going forward and back. And off of this, the 2 points that we want to set are, let's say, we'll make 2 variables here. Actually, we'll do this correctly. Variable type is a vector, and we're going to call this start lock and end lock. The start location we will set up at begin play, and we will set this to the actor location. So wherever it spawns in will be the start location. And end location, let's see. Let's say, let's just hard code this for now. So we're using the x-axis here. The end location is the actor location plus, hook that up, and we're going to add, say, 1,000 units on the x vector. And we want to lerp between those two. So A is start, B is end, compile and save. And now we have an object that's going to move in and out of the room collections, specifically this bottom one here. So let's see what happens. Let's actually do the top one here, because this bottom one might not fade out just because it's on the ground floor. So we've got that. Let's see if it moves back and forward first of all. Yep. Seems to be doing nicely, but it's not looping because we didn't set it to loop. So back in floaty sphere, we will go back into the timeline and just hit this loop button, compile and save, and hit play. It should now be moving back and forward. Yeah, you can see it moving in and out there. And let's see, can we get this to a location? It's not fading in or out though. Why is that? What's floaty sphere set to? Let's change that from block all dynamic to overlap all. So it is doing something, but obviously it's not fading out because it's not using the material, right? So let's put the material on the sphere. Environment, and that should work now. The reason why I figured that out so quickly is because I've got this log here telling me, there's nothing we're setting. So listen to your logs, folks. And now if we come back here, let's full screen it so we can actually see what's going on. You can see as it enters, it fades out, and as it leaves, it fades back. However, it's kind of a bit out of the way here. Let's see if we can get a better angle on it. Something like this. There we go. So as it enters the zone where we don't want it to be visible, it fades out, and it fades back in once it's out of the zone. Now, if we bring the character up so that the room is always visible, it shouldn't fade, right? So let's check that. So we're in the room, nothing else is faded, and that's not faded because we are on the same floor as it. Cool, that's working nicely. I seem to have broken the roof logic though, so let's see if we can figure that out. But I'll probably do that in the next episode. What do we want to do? We've got dynamic objects done here. We've occluded the environment. Let us also set up some logic for fixing up this floor, right? It's a bit ugly right now as it is. And we can make this a bit better with some added logic to the environment mask material function. So, yeah, I will leave that here and I will see you in the next video.